All right, so this is problem 50 from chapter 7. The problem says a 1,500 kilogram rocket is to be launched with an initial upward speed of 50 meters per second. In order to assist its engines, the engineers will start it from rest on a ramp that rises 53 degrees above the horizon. At the bottom, the ramp turns upward and launches the rocket vertically. The engines provide a constant forward thrust of 2,000 newtons. The friction with the ramp surface is a constant 500 newtons. How far from the base of the ramp should the rocket start as measured along the surface of the ramp? So if we draw a picture, we've got a ramp. It's going to come up and launch a rocket that's going to go up and go that way the whole time that the engines are burning. Probably be better if I redrew it down here. It's kind of more of a straight ramp down, curves upwards. The ramp has an angle theta. Yeah, you can see that better. And we want to know how far up the ramp we need to start the rocket. So we also know that the rocket has a mass of 1,500 kilograms. We have a force of thrust from the engine that is equal to 2,000 newtons. Force of friction of the rocket going along the ramp is equal to 500 newtons. And we need a velocity upward that's going to be equal to 50 meters per second. And we want to know how far up the ramp we need to start. So we know that the initial kinetic energy plus the potential energy plus the non-conservative forces non-conservative, has to be equal to the second kinetic energy plus the second potential energy. We know that at the bottom of the ramp, it's going to have zero potential energy because it'll have all been, like, the potential energy due to gravity will have all been turned into kinetic energy. And we know that it starts at rest, so its initial kinetic energy is going to be equal to zero. So we know that it's going to be equal to 0 plus mass times gravity times the height plus the other forces that are working, the work that's done, the other forces are tension and friction. So it's going to, or not tension, thrust minus friction, which is going to be equal to our kinetic energy, which is going to be equal to 1/2 mass times velocity squared. So we know everything except for the height. The height isn't what we're looking for, though. What we're looking for is the length up the ramp that has to start. So we know that the height is going to correspond to a length times cosine of theta, the angle of the ramp. So, or not cosine, sine. Sorry, my bad. Sine. It's the height, so it needs to be sine. Cosine would be the distance from where the ramp touches the ground. But we want how high up. So we can then substitute that in for h. beta, so 0 plus, if we do this, L times sine of 53 degrees is going to be equal to 4/5 L for the height. So substitute that in there, so we get mass times gravity times 4/5 the length plus the thrust from the engines minus friction from the ramp plus 1/2 is going to be equal to 1/2 the mass times the velocity squared. So then we just have to solve for L. So we can kind of forget about the 0. So then we can add everything in. So 1500 times 9.8 times 4.5 times L. I forgot something at the beginning. This should be work, not the force. And the work is going to be equal to force over distance. So this is going to be times by L. Force times the distance. So this is also by L, which is going to be equal to 2,000 minus 500 times the length of the ramp is going to be equal to 1/2 mass times the velocity squared. So this is the work done. So this is the force, net force times the distance, L, along the ramp. So we can then put L is equal to these two added together. So you do the math, this comes out to 11,760 plus 1,500 is going to be equal to, then this would be 1/2 1,500 times 50 squared, because that's the final velocity that it needs to have when it's coming off the ramp. And that, when you do the math, is equal to 1,875,000 joules. So we then divide both sides by this, so the length is going to be equal to that divided by this. And you find that the length that the rocket needs to be started up the ramp is equal to 141 meters.